Good day once again, grade 9s. In the next couple of videos, we are going to look at chemical formulas and where do they come from and how do you write them. You might have looked at some of these chemical formulas before and thought to yourself, why is it written like this? Where does the numbers come from? So that is what we are going to try and establish, but in order to do that, we need to establish a good foundation to work from. So that is what we're going to do in this first video, is understand some of the underlying work in order to understand the chemical formulas a bit later on. But before we do that, we're just quickly going to go over the activities you had to do in the previous video. So the first activity you had to do is you had to complete this table. Now here's all of the answers. I'm not going to go through every single line. You can pause the video and make sure you have all of the correct answers. If you don't understand something, feel free to ask me through all of the various avenues through which you can contact me. And for the second part of the activity, you had to draw a beryllium atom. Now it is very similar to the lithium atom we drew in the previous video, but in this case it has a few more electrons, protons and neutrons. So the amount of electrons is 4, the amount of protons is also 4, and the amount of neutrons is 5. So make sure your drawing has these same numbers of subatomic particles, and if you got it wrong, you're going to have to go back to the previous video and look at our analyzation of the periodic table and make sure you know how to use these numbers. Because if you don't know how to use them, the work going forward is going to be quite difficult for you to complete. Okay, so in this lesson, we are going to learn a few new concepts and we are going to see how these concepts tie into chemical formulas. So one of the main concepts you're going to learn about is valency and valence electrons. Okay, now this is completely new words, so don't worry. Okay, just remember by the end of this lesson, you should understand what valency is. And you should know how to get the valency from the periodic table. And we'll learn all of that in this video. So first we are going to look at chemical formulas and try and understand what these numbers mean. The first number in front is called the coefficient. This tells us the number of molecules in this formula or equation. The small number is called the subscript, and these numbers are found after the letters and they tell us the number of atoms in each molecule. So in this case, there are 2 hydrogen atoms in this molecule, but what about oxygen? Why is there no number over there? Well, if there's only 1 atom in a molecule, then we don't write the number. So in this case, there's an imaginary 1 after the O for oxygen. So water consists of 2 hydrogen atoms and 1 oxygen atom. And if there's a 2 in front of H2O, then it means there are 2 water molecules. So let's do a few calculations just to ensure that we understand these numbers. Okay, so if we take a look at just H2O, so we just look at 1 water molecule for now, then we can see that after H we have a 2, so that means there are 2 hydrogen atoms, and after O we have no number, meaning there is 1 oxygen atom. Okay, and this forms 1 water molecule. Now if we have 2 water molecules, so we add a 2 in front, then we multiply this 2 by with every subscript, so with every number after a letter. So in the first case, for hydrogen, we say 2 times 2 equals 4 hydrogen atoms, and 2 times this imaginary 1 will give us 2 oxygen atoms, and in total you can see that there are 2 water molecules. Okay, so this is very important for later on, so I'm going to recap this in a later video, but I believe that this is quite simple and straightforward, so it shouldn't be too difficult for you guys to do. Then we just have an activity to test your understanding of the work that we just discussed. So you have to complete this activity. It's very simple. All you have to do is calculate the total number of atoms in each of these formulas. Okay, but I will show you this activity at the end again, because I first want to go through all of the work, and then I'll show you the two activities that you have to complete at the end. So you don't have to write this down right at this moment. So at this point you might be wondering to yourself, okay, great, I know what these numbers mean, but where do they come from? Who decided that water is H2O? Why can't it be H3O? Or why can't it be H4O5? That is what we are going to do in the second part of this video, is figure out how these molecules form and understand why they form in certain ratios. So basically, where does these numbers come from? So in order to understand how atoms bind together, you have to understand the concept of valency. Now, valency is the overarching concept that we're going to be looking at for the rest of this video. But before we get there, we first have to look and understand valence electrons. Now, valence electrons are simply the electrons in the outer orbital. So if we have a look here at the sodium atom, we will see that in its outer orbital, it only has one electron. It has a bunch of electrons in its other orbitals, but those don't count. So we only count the number of electrons in its outer orbital. If we have a look at another example, chlorine, then we can count up the number of electrons in its outer orbital, and we'll see that it has 7 valent electrons. Now you might remember from the previous video when we looked at the periodic table, when we discussed groups, we said that the group number is equal to the number of electrons in the outer orbital. And I told you that will be important for later on. Now is later on. So the group number tells us the number of valent electrons. So we can say valent electrons is equal to the group number. So if you remember this, it will make your life a lot easier later on when you do the activities. But what is the point of all of this? Why is this important? Why do we need to know the number of valent electrons? Well, you see, chemistry is actually a very romantic and sometimes quite tragic love story. Remember that I told you that the first orbital of an atom can hold 2 electrons, and the second and third can each hold 8 electrons. Now atoms, just like humans, have an innate desire to feel whole and complete. They don't like having open spaces in their outer orbital, and they always strive to have full orbitals, even if it means giving up some of those electrons. So these atoms are continuously searching for another atom to complete them, an atom that fits their valency perfectly. And just like in any other relationship, someone has to give and someone has to take. So the atom with the fewest valence electrons will donate its electrons to the other atom to complete its set of valence electrons. And by doing this, they are bound together through a chemical bond and live happily ever after as a compound. Unless, obviously, if one wishes to decompose, in which case, like in real life, one party is always more negatively affected by the decomposition reaction. But we'll discuss more on this a bit later on. So for now, understand that these valence electrons is what atoms use to share with other atoms to form chemical bonds. So let's look at this simple example of the formation of water. Oxygen has 6 valent electrons, meaning it still has 2 spaces open for electrons. So it has 2 binding sites where something can bind to the oxygen. While hydrogen has 1 valent electron and 1 open space. So if hydrogen were to bind with oxygen, then it will only fill 1 of the spots, or 1 of the binding sites. Luckily, atoms aren't the jealous type, and they are quite indifferent to polygamy. So if you add another hydrogen atom, it can fill that open electron spot, meaning that all of these atoms now have their outer orbitals filled with electrons, meaning all of these atoms are content. And that is how we arrive to the formula H2O. But this is quite a tedious process to get to this formula. So what can we do to simplify this process? The solution is valency. Valency is the combining power of an element and is measured in the number of electrons an atom either donates or accepts, and is represented as values between -4 and +4. So in the previous example, oxygen had a valency of -2 because it accepted 2 electrons from the 2 hydrogen atoms. And each hydrogen atom had a valency of +1 because it donated 1 electron to each oxygen atom. A positive valency indicates electrons lost, while a negative valency represents electrons gained. For example, if we look at an atom X, which has 3 protons and 3 electrons, it would be neutral as the positives and the negative charges cancel each other out. When the atom loses or donates an electron, it will become positive because it has more positive charges than negative charges. And when the atom gains an electron, it becomes negative. We call these positive and negative atoms ions. But don't break your head over this, as this is not that important for grade 9. What is important is that you understand how this affects the chemical equation. So let's imagine 2 atoms, X and Y, each have a valency of one have a valency of +1 and the other one have a valency of -1. This means they will cancel each other out and will bind in a ratio of 1:1 to form a compound called XY. However, if Y has a valency of -2, it would require 2 X atoms to cancel out the valency of the Y atom, meaning they will bind in a ratio of 2:1 to form a compound X2Y. If you're a bit lost at this point, I recommend that you re-watch this section as it has a lot of information for you to remember. But the next part is very simple, so don't worry too much, as I will show you in the next part how all of this comes together. So the good news is you don't necessarily need to understand what valency is or how it works in order to do a lot of the work that we're going to do in the future, but it obviously does help. All you actually need to know is the valency for each element and how you can tell that by looking at the periodic table. So the valency is not normally given on the table, but it corresponds to the group number. So all you need to remember is the valency for each group. I've included the valency in this table just so that we can see what group corresponds with what valency. So group 1 has a valency of +1, while group 2 +2, group 3 +3, and then group 4 is ± -4. So we'll get back to that in a second. Then if we get to group 5, we see that it now goes in the different direction. So now -3. Then group 6 is -2, and group 7 is -1. Then group 8 we see has a valency of 0. So this is quite interesting. Since these atoms or elements in the last group already has a full outer orbital, it has no reason to want to bind to any other atom because it already has a full outer orbital. So it is like the Mr. and Mrs. Independent of the group, as they don't need to bind with any other atom to feel complete since they already complete themselves. So if you can remember all of these valencies, it will make it a lot easier when you have to do the calculations in the later sections. My recommendation for tests and exams are that you write down the valencies on the periodic table that will be given to you. But it is important that you understand or that you know which group corresponds with what valency. So make sure that you know this, and we are going to test this in the activity that we're going to do. So here's the activity from earlier on in the video. So all you have to do is you have to count up the number of atoms in each of these chemical equations or chemical formulas. So go back and see the method that we used earlier on, but like I said, this is quite a straightforward and simple activity. Then the second activity you have to do is you have to draw and complete this table of the first 20 elements of the periodic table, and you have to fill in all of this information. But all of this information is very simple to get, and I've done the first 7 for you so that you can see the pattern that it follows. And the important part here is the valency. So this last column, the valency, is the important part that we want you to get from this exercise. But all of the other information helps you to get there and also informs the valency. So draw this table, complete it, and you will have a better understanding of valency. And I promise you, we're not just doing this because we think it's funny. We're doing this because in the next couple of videos when we do the equations and the chemical formulas, this information is vitally important. Okay, so I see you guys in the next video.